So today,
We are present to you
Kinematic motion.
in a straight line. So let's watch our
Role play.
Good morning to you, teacher. Good morning to you, teacher.
Good morning, everyone. Have a seat. So today we will learn about constant acceleration. Have you ever heard about constant acceleration? No. You? Like this.
First, we need to understand what is acceleration. Acceleration is the rate of change of velocity. This means when an object changes its speed, whether it becoming faster or slower, we say that the object is accelerating. Now, let's move to constant acceleration. Constant acceleration is actually one type of acceleration where the acceleration remains the same at all time. If you look at this acceleration over time graph, we can see that the acceleration is remain constant, shown by a straight horizontal line. If we change that graph into velocity over time graph, we can see that the velocity increase over time, forming a straight line. This means that the velocity increase in the same amount at the equal time interval. Therefore, constant acceleration is when the object travels with the speed that change by the same amount each second.
Now, let's move to the formula of constant acceleration. There are 5 equations that can be used in this situation. These are sometimes called as Sueanne equation. Sueanne, can you explain to me what is Sueanne and give me one example from it?
Yes, sure, teacher. Let's go. Sueanne equations are used to describe motion in a straight line with constant acceleration. Means the acceleration does not change with time. The word Sueanne represents 5 important quantities: S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. The first equation is V equal U plus AT. This equation is used to find the final velocity when the initial velocity, acceleration, and time are known.
Good job, Anne. Now, I want to hear another 2 from Irfa.
Now, let's look at Sueanne equation number 2. This equation contains S, which is displacement, U, which is initial velocity, V, which is final velocity, and the last one, T, which is time. Notice that this equation does not include acceleration. So, we use this equation when acceleration is not required, but displacement, time, initial velocity, and final velocity are involved. Next, let's look at Sueanne equation number 3. This equation contains S for displacement, U for initial velocity, A for acceleration, and T for time. This equation does not include final velocity, which is V. So, we use this equation when the final velocity is unknown and not given in the question.
Great job, Irfa. Now, I want to hear another from Marissa.
So now let's continue with the last 2 formulas, which is V square equal to U square plus 2AS and S equal to VT minus 1 over 2AT square. So let's start with this formula first. So the formula is V square equal to U square plus 2AS. In this formula, we have V final velocity, U initial velocity, A acceleration, and S for displacement. This formula is used when the time is not given in the question. Last but not least, we have S equal to Vt minus 1 over 2 At squared. So, in this formula, we have S for displacement, V for final velocity, A for acceleration, and T for time. We use this formula when U, or initial velocity, is not given from the question.
Great job, everyone. Do you understand about constant acceleration?
Yes!
Okay, now let's do some exercise. Ifa, I want you to answer the first question. Sure, teacher.
Now, let's read the question first. A truck covers 14 meters in 8.5 seconds while uniformly slowing down to a final velocity of 2.8 meters per second. For question A, find the truck's original speed, and B, find its acceleration. In this question, a truck is moving in a straight line and slowing down uniformly. This tells us that the acceleration is constant, so we can solve it using Sueanne equation. Firstly, I will list down all the Sueanne equation. Then list what we know. The initial velocity and acceleration are unknown. So we have S equal to 40 meters, T equal to 8.5 seconds, and V equal to 2.8 meters per second. So to answer the question A, we use the second Sueanne equation, which is S equal to 1 over 2 U plus V T. Then substitute all the given information in the formula. The final answer is U equal to 6.61 meter per second. For question B, we use the Sueanne equation number 4, which is S equal to Vt minus 1 over 2 At power of 2. Then substitute all the given information into the formula. Then we get the final answer is A equal to negative 0.448 meter per second square. Notice that the acceleration is negative, which confirms the truck is decelerating. Also, the initial speed is higher than the final speed, which matches with the situation described.
Okay, now let's move to the second question. Who want to do the next question?
Me, teacher!
So now let's move on to the next question. Let's read and understand the question carefully. A car is moving with constant speed of 80 km per hour when suddenly the driver sees a cat 50 meters straight ahead of the car. The driver's reaction time is 0.5 seconds and the maximum deceleration of the car is 10 meters per second square. Calculate total distance traveled by the car from the moment the driver sees the cat until it stops. What happened to the cat? Given in the question, initial speed u equal to 80 km per hour, reaction time is equal to 0.5 seconds, maximum deceleration a equal to minus 10 meter per second square, distance to the cat is equal to 50 meters. So, our task is to calculate the total distance traveled by the car from the moment the driver sees the cat until the car stops, and then decides what happens to the cat. First, from the moment the driver sees the cat, the driver does not brake immediately. So, the driver needs 0.5 seconds to react. During this reaction time, the car continues moving at the constant speed, so there is no acceleration. We need to calculate the reaction distance using formula S equal to ut, since there is no acceleration. Next, after the reaction time, the driver presses the brakes. Now, the car starts to slow down with a deceleration of 10 meters per second squared until it stops. This distance is called the braking distance. Let's start with the working. Step 1, we convert the speed, which is 80 km per hour, then we get 22.22 meter per second. Next, calculate reaction distance at t equal to 0.5 seconds. Using the formula S equal to ut, we insert the value and we get S equal to 11.11 meters. So the car travels 11.11 meter during the driver's reaction. Next, calculate braking distance. So after reaction time, the driver applies brake and the car decelerates at A equal to minus 10 meter per second square until it stops, means V is equal to 0. We use the formula V square equal to U square plus 2AS. We insert the value of V, U, and A, and then we get S equal to 24.69 meters. So the braking distance is 24.69 meters. Then we calculate total stopping distance, which is reaction distance plus braking distance, and then we get 35.8 meters. So what happened to the cat? We get from the question, distance to the cat is 50 meters. Then we have calculate total stopping distance, which is 35.8 meters. So since 35.8 meters is less than 50 meters, so the car stops before reaching the cat. So therefore, the cat is safe and is not hit by the car.
Okay, now let's move to the second topic, which is vertical motion. So I would like to conduct an experiment before we go further. So Sueanne, can you conduct the experiment for this topic?
Yes, teacher.
The object is thrown upward, and this is maximum height of the object, and object drop from rest.
In vertical motion, we usually use these three main formulas. And acceleration is to remain constant, which is negative 9.81 meter per second square.
Okay, good job everyone. So now I want to share with you one question from vertical motion.
Now, let's look at this question. A ball thrown straight up into the air is found to be moving at 1.50 meter per second after rising 2 meter above its release point. Find the ball's initial speed. From the question, we have the information of first, final velocity or V is 1.5 meter per second. We also know the distance or S is 2 meter. Since it's a vertical motion, so we know that the acceleration is negative 9.81 meter per second square. And now we are required to find the initial velocity or U. If we compare this information with Suvet, we only have S, U, V, and A without T. That means we can use this formula. Since all information are in the same unit, we just need to enter it into the formula. So it will go like this. Then, since we want to find U, so we make U as the object. Now, we can solve the equation. And at the end, we got the initial velocity or U as 6.44 meter per second. And that's the answer.
Okay, now let's move to the last question.
Teacher, can I answer the last question?
The last question is a drunken motorist who is moving at a constant velocity of 90 km per hour passes a stationary police patrol car. The patrol car immediately gives chase at a constant acceleration and catch up with the motorist after a distance of 10 km. A. Calculate the time taken by the patrol car to catch up with the motorist. B. Calculate the acceleration of the patrol car. So, the solution is, first, we need to list down the Suvat equation so that it will be easy for us to solve this question. The first question is, calculate the time taken by the patrol car to catch up with the motorist. So, we need to draw the diagram to be more understand about this question. Given that the motorist speed is 90 km per hour at constant velocity, police car start from rest, and distance to catch up is 10 km. The step 1, we need to convert unit to the SI unit, where for 90 km per hour, we convert to 90,000 meter per 3,600 and it will become 25 meter per second. Then, for distance, 10 km times 100 equal 10,000 meter. Step 2, we need to use SWOT formula. Since motorist has constant velocity, so acceleration equals 0. Then we will use the second formula, which is S equal ut plus 1 over 2 at t square. Given that S equal 10,000 meter and u equal 25 meter per second, then we substitute the old value and we will get the value of t, which is 400 seconds. So, the motorist reaches the 10 km in 400 seconds. Next is calculate the acceleration of the petrol car. Step 1, we need to use second formula, which is S equal ut plus 1 over 2 at t square. Given that S equal 10,000 meter, t equal 400 seconds. The times is 400 seconds because both vehicles were in the same position at the time of capture. So, the times is same for both. Last is u equal 0. Then, we substitute all the value in the formula. Then we will get the answer, which is 0.125 meter per second. Therefore, the police car accelerates constantly at 0.125 meter per second.
Okay, so before we end our class, I want to conclude what we have learned today.
In conclusion, motion with constant acceleration can be analyzed using these five equations. This equation can be used and help us to determine the unknown quantity, such as displacement, velocity, time, and also acceleration. However, not all these equations can be used at the same time. We need to select the most suitable equation based on the given information and find what we want to find. For the vertical motion, these three super equations are applied, but the acceleration is due to gravity. The acceleration is usually taken at negative 9.81 meter per second square. This shows that the gravity always acts downward regardless of the direction of the motion.
Terima kasih.
Thank you. 谢谢. Nandri.
Bonsico.
Arigato.
Shukran.
감사합니다.
Bye.
Bye.
Like this. Jadi
Imagination.
Belum kan?
Teacher, can I... sorry. Teacher, I want to ask...
Sure teacher. Aku boleh berak.
go.
Yes.
Terima kasih.
Terima kasih.
Nandri.
谢谢. Thank you. Terima kasih.
Nandri.
谢谢. Stand up.